Okay.
So, Holly, thank you for being here. Um, Seems that I got the dates wrong, so I apologize for that. But thank you for recording this, and then I'll post it up and then we can share it.
That sounds great. Well, thank you for the invitation. It's always a pleasure to talk to your network. So I'm happy to make a recording with you.
So would
Let
you,
me
yeah,
go ahead.
introduce yourself, if you would.
Yes. If you don't mind, I am going to get my presentation queued up and then I'll introduce myself. Hang on. I think I have to share my screen first and then go into presentation mode. Oh, there it is. All right. Are you seeing the presentation version or the slide notes version?
Uh, well, I've got notes at the bottom here. So I think
Subtitles?
subtitles are not currently available. It's what it says.
Okay. Okay. Um,
That's fine.
okay. Well, I will just present like this. Um, thank you so much for having me here. My name is Holli Kohl. I work on Globe Observer at NASA Goddard Space Flight Center. Um, so GLOBE is an acronym, like everything at NASA. It stands for the Global Learning and Observations to Benefit the Environment. It's an international science and education program that engages students and volunteers worldwide in collecting environmental data in support of Earth system science. So I work on Globe Observer, which is the app of the GLOBE program, and it's the primary way that volunteers outside of a school setting engage with GLOBE. And so today I'm really excited to come talk to you about Globe Eclipse, which is a tool in the Globe Observer app. So I wanted to start with a little bit of a thought experiment. I want you to close your eyes and imagine it's a warm spring day and the sun is shining on your face, and it's really nice because it's been cool and it's nice to be in the sun, and you just have your eyes closed and you feel the sun on your face, and then all at once um, that glow between your eyes darkens and it starts to get a little bit cool. You open your eyes and you see that a big cloud has moved in front of the sun. And it's moments like this where we really appreciate the connection that we have to the sun. Um, we live on a solar powered planet, so the sun influences our temperature. It heats the ground, which evaporates water to form clouds. It heats the atmosphere. It creates pressure differences that fuel winds. It gives us energy, gives energy to plants, plants that we need to survive ourselves. So we rely on the sun in every way. So, what we're asking is what happens when the sun is blocked, even temporarily, during an eclipse? Um, I would ask you what you think. What do you think would happen? Um, it's going to get a little cold in that moon shadow. And then what happens to the clouds? The clouds that form and are fueled by those solar processes. Well, the solar eclipse coming up here in April gives us an opportunity to have a natural experiment and test it out and see what happens. So, as part of GLOBE, we invite you to participate in this experience by measuring the temperature and observing clouds throughout the eclipse. We also ask that you use land cover, Globe Observer land cover, to show us what's on the ground where you are when you are observing the eclipse. And the reason that's important is what is on the ground may influence how much the temperature changes and other kinds of atmospheric changes that might happen around you during the eclipse. To explain kind of how this might be, I'm going to share two experiences. In 2005, I got to see my first total solar eclipse. I was on a beach on the Mediterranean Ocean, And it was a really, really warm spring day. It was in April, like it is this year. And it was a warm day. It was kind of uncomfortably warm. And as we sat on the beach and waited for the eclipse to happen, um, as the sun became more and more eclipsed, it started to get cold. And the wind started blowing and the waves started kicking up on the ocean, or on the Mediterranean. And we started to see these clouds moving in from the water as the shadow came closer to us over the water. Now contrast that to 2017. And this time it's summer and it's also a warm day. And I was in a farm field in Idaho. And there wasn't much water around me. It was pretty flat still, but it was mostly, plants and a few trees here and there. And as the eclipse started to happen, I really didn't notice any changes to clouds or to the wind. It did get a little cooler, but it wasn't as dramatic. So, what's on that land, that big body of water next to me in the Mediterranean, really influenced that experience. And we're curious at what is that? How does that play out across a larger geographic region? So that's why we're asking for clouds, temperature, and what the land is. So I'll go into more detail about how to make that observation in a moment, but all the data that we do collect during the eclipse will go into the GLOBE database, where it is available freely for anybody to download, but particularly for student research and for science research. Publications that we've had based on past eclipse data are on the Globe Observer website. And there's both the peer-reviewed science publications as well as student research. And this year in 2024, for the April eclipse, we are anticipating supporting some really interesting student research with some internships this summer, as well as, Globe encourages student research year round. So I'm excited to see what students come up with in terms of eclipse data. We also have some scientists lined up to do some analysis of the data. So I'm looking forward to seeing what we learn from this. So the air temperature data collected by GLOBE participants, this map is showing the air temperature data collected by GLOBE participants during the total solar eclipse on the 21st of August in 2017. And I'm going to play this animation for you. Let's see. Here we go. So the dots are temperatures, and the warmer temperatures are the reds and the oranges, and then the coolers are blue. I want you to notice what happens in the center of the shadow as it goes over. What happens to the temperatures? So I'm going to pause that there. What you would notice is that the colors change just a bit, maybe from these darker reds to the oranges, um, as the eclipse shadow comes and passes, and you get the coldest, the lowest dip in temperature just after that shadow passes. So now I'm going to, if it will let me, let's go back just a bit and we'll watch it one more time. And this time, pay attention to what happens on the edges. Let's see. I'm going to let it play here. So notice that you might not see as much change, but you still see change. And these are areas on the edges of that circular shadow there that are getting some form of eclipse, but they're not getting the total eclipse. I show this to make the point that we need observations everywhere. So no matter how much of the eclipse you are experiencing, the comparison data is really useful and kind of interesting, and you may still see some change. I think in Arizona, the April eclipse, you're definitely not in the path of totality, and I forgot to look up exactly how eclipsed you are, but I think it's in the 70% range. Oh, go ahead.
64.
64. Okay, I know we're closer to like 85 in Albuquerque, so that's why I was guessing 64% eclipse. But I still think that's 64% of the solar energy that is that is not reaching the surface. So I'm really curious to see what the temperature change is there in Arizona, particularly since you're pretty dry. And I think that just that shadow is going to make a pretty big difference. Let's see. So pause here. Anytime you're talking about eclipse, doing eclipse events, we have to talk about safety. So as I'm sure you know, never look at the sun directly without solar viewing glasses. Um, it's never going to be safe to look at the sun. In the path of totality, if you're traveling and you happen to be in that path of totality, you can remove the glasses just during totality, but at every other time, they need to be on when you look at the sun. And make sure the glasses, if you order them online or whatever, that it has that ISO 12312-2 standard. It meets that standard. And should be able to, when you get the glasses, hold it up to a light, and just like a room light, and just see a little tiny bit of light coming through, just a little prick of light coming through, and that will tell you that they're okay to use. But you can also use indirect viewing methods. We have on our website a few different ways of making pinhole viewers or indirect viewers, but you can use anything that has holes in it, like a colander, or I had some little beach toys that I was using, even like your hands interwoven, leaves on the trees, all of those things that create holes that you can see through the shadows will project the shape of the sun onto the ground. One thing I found in the October 2023 annular eclipse, when I was doing indirect viewing with a group of people, is that you do have to show them how to do that. That you use the object and put your back to the sun, use the object to cast a shadow on a surface on the ground. So, and then look at the shadow to observe the eclipse. What I found was I was handing out these eclipse cards that you see in the picture there, that they have a little hole in the center that we use for indirect viewing. And people were taking those cards and holding them up to the sun to look at the sun through the hole. And I was surprised how many people tried to do that. So you do need to instruct people that back to the sun, looking at the shadow on the ground. All right, so I want to show you a short video about how to do the globe eclipse protocol.
Planning to watch the eclipse? With just your smartphone and a thermometer, you can help contribute to our understanding of how the eclipse affects our atmosphere. Even if you will only experience a partial eclipse from your location, your observations are still valuable. Start by downloading the Globe Observer app. You will need a connection to the internet and access to email in order to set up an account. So you should plan to do this step before the day of the eclipse. Complete the brief in-app tutorials for land cover and clouds. Don't worry if the eclipse tool isn't visible in the app yet. It will appear closer to the eclipse. Next, find a thermometer that you can use to measure air temperature at your precise location. Remember, the temperature in your weather app is from a weather station that may be far away. You can check the accuracy of your thermometer by putting the probe in an ice bath. After 10 minutes, the thermometer should read between plus or minus 0.5 degrees Celsius. On the day of the eclipse, plan to take observations for an hour or two before and after the eclipse. The longer that you take measurements, the easier it will be to see changes in the air temperature. Be sure to pack everything you need to be safe and comfortable during the eclipse. Look for an area with a clear view of the sky, while being cautious of uneven ground, moving vehicles, and other hazards. Once you're set up, launch the Globe Observer app and open the Eclipse tool. You'll start by choosing between Celsius and Fahrenheit and selecting the type of thermometer that you will be using. Next, use the land cover tool to document your observation site. You will take photos in each direction, as well as up and down. Include your thermometer in one of your photos. Enter your first temperature measurement and observe the sky using the Clouds tool. The app will prompt you to take temperature measurements every 5 to 10 minutes leading up to and after the eclipse. If you notice any changes in the clouds, use the Clouds tool to document these changes. Feel free to add captions to your photos with observations of the wind, animal behavior, and any other changes that you experience. Now you're all set to observe the eclipse. Remember to take a break during maximum eclipse to enjoy this incredible experience. Learn more at observer.globe.gov/eclipse and download the Globe Observer app from the Apple App Store or Google Play.
All right, so that video, as well as, whoops,
Planning to watch the eclipse?
here we go. That video, as well as all the resources that I'll be talking about today, including the app, are available in Spanish on our website. So to get ready for the eclipse, you'll need to gather a few resources. One of the things that I recommend, of course, you need to get the app itself. The app is available on Google Play and Apple App Store. And it's free. You just have to register with an active email address, and you want to do that well ahead of time. And then starting early next week, late March, you'll be able to see the Eclipse tool inside the Globe Observer app. It's not there routinely. We only release it during the eclipse. And we'll have it there a little early this time so that you have a chance to go through it, look at it, familiarize yourself with it. You can even try practice entering data. None of the data will be stored, so you can just, dummy data is fine. So right now it's in this practice mode, so you can check it out and do whatever you need to get familiar with it and comfortable with it. And then we will open it up for real data collection starting a week before the eclipse. I like this picture here on the right because the app is sitting on top of a paper data sheet. And I really recommend using a paper data sheet if you're doing this with a group of people where not everybody has the app or an app, a cell phone or a tablet. And also during the eclipse, connectivity can be an issue. So it's really nice to have that backup paper data sheet, particularly when you're working with a group. You can upload the data later in Globe. We can help you with that. We do have a paper data sheet on the Globe Observer website. I'll show you where in a few minutes. And we also have an Excel version of that data sheet. So it's just trying to make it as easy as possible for you to collect that temperature data. So first, after you download the app, you need to find a thermometer to use on the day of the eclipse. Any air temperature thermometer will work just fine. The only thing that does not work is the weather app on your phone, as the weather station could be quite far away. And as we talked about, your exact location, the land cover at your location, just the topography of your location, all of those things may change how the temperature is changing during the eclipse. So we want to have that thermometer on site where you are. We do have a list of equipment suppliers on the website. There's a URL here, which I will provide. But most any thermometer will work just fine. So you want to calibrate your thermometer ahead of time. So put it in that bath of ice water, and you're going to measure that temperature. You want it to be plus 0 degrees C, plus or minus 0.5 degrees C. That translates to 32 Fahrenheit, plus or minus 0.8 degrees Fahrenheit. So 32.8 to 31.2, all of those are okay. Once you have your thermometer all set, you're ready to go. So the day of the eclipse, you're going to want to put your thermometer somewhere in the shade. An instrument box is ideal, but I recognize most people are not going to have that. So anywhere, like shade of a tree. I put it just under, like hanging behind a chair, like a lawn chair that I had sitting out for the eclipse. So it still had enough air circulation, but was in the shade the whole time. Even your own shadow would help. So put it somewhere in the shade. And then you're going to set up the app, and you want to do this an hour or two before the eclipse starts. So you're going to enter the type of thermometer that you're using. You're going to tell us what scale you're using, Celsius or Fahrenheit. All of the data is going to be stored in Celsius and the Globe database, but just to make it more comfortable for everybody in the United States who uses Fahrenheit, we provide that option. And then you're going to want to turn on those alarms for taking measurements. There's something about an eclipse that just distorts time, and we're asking for regular measurements every 5 to 10 minutes, depending on when we are in the eclipse. And it's just really easy to lose track of time. So turn on that alarm and that will help you out. Then the app will fill in your current location. You can change that if it gets it wrong, but that is just automatically set for you. And then the last step in your setup is to take a land cover observation. And that entails taking photos north, south, east, west, straight up and straight down. And then in land cover, there's a place where you can have a special photo, a special feature photo. And in that photo, if it's not in one of your north, south, east, west photos, include where you set up your thermometer so we can see kind of what the setting is for the thermometer. So here's the home screen of the Globe Observer app. You see at the top underneath the eclipse title is that arc with the sun and the moon. And you see the time of max eclipse there and your current time, so you can see how close you are to the maximum eclipse. And then that little moon is going to move across the screen as the eclipse progresses. Underneath that, you see 3 buttons that help you navigate to different sections of the app. The red button with the triangle is our safety pages as well as the introduction pages. The center button, the blue one with the little gear, is the settings button, which is basically everything you had on the previous slide. So if you start taking measurements and realize your thermometer is in Celsius, not Fahrenheit, you can go swap it. And then the last button is where you see the data that you've entered. And I'll show you that a little bit more. When it's time to enter data, you'll see the button underneath your 3 buttons says next observation. It tells you how long you have until it's time to enter your next air temperature data. And then when it's time, it'll change to that blue enter data now. So you tap on that and that menu will pop up, that drop down menu will pop up. So you just scroll until you get to the current temperature, select your temperature, and then you say done, and it saves that temperature for you. And then the timer resets for your next observation. So once you have a few things, any data in the system, that little green graph button will have a little number next to it. So you can see how many observations you've entered. You can tap on that to see the data you've entered, and that data can be edited if you need to. So if you realize that you were off by 10 degrees or something like that when you take your next observation, you can go correct something. So ever so often, you'll be asked to take a cloud observation. There's the button underneath the graph that says new cloud observation. We ask you the reminder will pop up every 30 minutes, and then it will shift to 15 minutes, about half an hour before the eclipse. But we encourage you to take that observation anytime that you see something changing. So to take a cloud observation, you're going to tell us what the overall cloud cover is. I hope it's nothing for you, but you'll tell us what your overall cloud cover is. You'll estimate how much of the sky is covered in clouds. You'll tell us what your sky conditions are. So is it hazy, or is your sky really blue? What's your visibility? And then you'll tell us the cloud type. And the app has a key that will help step you through identifying the cloud type. So it's not something you're familiar with. That's okay. We'll help. And then you take pictures of the sky, north, south, east, west, a lot like land cover, straight up and straight down. And the app will kind of guide you through that, so you don't have to know where north or south is to use this tool. All that training is in the app, so you don't have to remember it. We'll guide you through the process. So for clouds, you're going to make those observations every 15 to 30 minutes. Like I said, you can do them more often if you like, and especially if you notice something changing. That is about every 3 air temperature measurements, you'll be making a cloud observation. Feel free to add any narrative or comments to your photos about anything interesting you see. So when you take a cloud observation, you'll get a summary of the photos. And then underneath the photo field, you'll see a caption field. You can tap there and enter any kind of extra observations, like starting to see animal changes or really interesting shadows or whatever you want to comment on. So every time you enter data, the graph on the home screen of the Eclipse tool will update. So you can see your new data points. You'll see the line graph on top will be your change in air temperature. And then the bar graph underneath is the change in overall cloud cover. And then you are able to share that graph by tapping share graph, and it will share on social media, or you can download the picture and save it to your pictures to use however you like. So one thing we're doing this eclipse that we haven't done before, but we're excited about, is that we are holding a cloud challenge. We're calling it the Globe Eclipse Challenge: Clouds and Our Solar-Powered Earth. And that's to give everybody a chance to practice making cloud observations and also to provide some comparison data for both before and after the eclipse. The challenge runs March 15th to April 15th. And the idea is to prepare you for that eclipse data collection, to add to a long-term data record to track change over time. Our first cloud challenge was held in 2019 in the same time period, so it'll be really interesting to have that comparison data. And what we're asking folks to do is to take cloud observations at different points during the day so we can see the impact of solar energy, first thing in the morning when you're just starting to get a little bit of solar energy in the atmosphere versus midday versus evening, and how is that changing across the day? And then how do those diurnal changes compare to those sudden rapid changes in solar energy we see on the day of the eclipse? So that's something you can start doing right away. Another resource that you might find useful, particularly if you're working with students, is that we do have a solar eclipse journal page where, if you're not going to do the app or the protocol, maybe you just have this as a reflection space where they record some of the things they noticed. They can talk about, if they notice the change in temperature or clouds or animals or whatever, they can record it on the solar journal page, which we have on our Eclipse resource library. I do want to quickly tell you about a companion project that we've been working with. This is the NASA Eclipse Soundscapes. They're funded by NASA under the same program that we are, and they're studying how eclipses affect life on Earth. They're collecting multisensory observations and they're recording sound data. And there are a number of roles that you can, if you want to do this, that you can take. The one that is probably the most accessible is the observer role, where you write down kind of what you notice about animal and insect behavior during the eclipse, what time it is, where you are in the eclipse. And then they especially want this information to complement the globe data. So they want that in the same place. So if you have a team of students, would be an ideal way to do this. You have some tracking temperature and some looking at animal behavior, and they can work together as a team to create this complete picture of what's changing during the eclipse. The other role, so there's more information about how to be an observer on their website, eclipsesoundscapes.org. They have some really great instructions. They have training. They do have a live training on March 18th and March 20th, if this is something you are interested in. So I encourage you to go look at their website. We also have some additional resources that you might find valuable. There's resources for individuals on the observer.gov/eclipse page. There's a resource library for individuals. All things are available in both English and Spanish. And then we have a number of resources. Well, the Eclipse library there has resources for individual observers. We also have resources for people who are leading a program, or informal educators or teachers. So this is basically for people who are facilitating a group experience. There's a number of activities that work well with a group. presentation. These slides are all from there, and again, also in English and Spanish. So I encourage you to check that out. If you are going to do Globe Eclipse with a group, what I found in October of 2023, when we did the annular eclipse in Albuquerque, is there are two activities that I found worked exceptionally well with groups. And I was in an event where I was working mostly with family groups of all ages. So one thing I did is I tracked the temperature on a big poster board. I had it in the app as well, but I was adding the temperature to the poster board so that it was a group experience and everybody could see the temperature change. And the reason that worked is that people were noticing the change and they would come and look and see what the change was because they didn't have a way to monitor it themselves on the day of the eclipse. They weren't there with thermometers. And then I noticed people coming back even the next day, because this was a multi-day event, coming back the next day and standing in line and waiting to come see this graph because they really wanted to know exactly what happened, how much the temperature changed during the eclipse. So this was a really, really effective way to have a conversation, to make that data collection a group experience, and then to facilitate learning. The other activity that surprisingly worked really, really well is the cloud in a bottle demonstration. Now, if you haven't seen that, we do have videos and instructions about how to do the cloud in a bottle, but essentially what it is you put a little bit of rubbing alcohol in a 2-liter bottle, you seal it up, and I have a little, like just a needle, like for inflating a ball, that I attach to a bicycle pump, and I pump up that bottle until there's a lot of pressure in there. Then you release the cork out of the top of the bottle, and that change in pressure will create the alcohol to evaporate and create a really impressive cloud in the bottle. And the neat thing about that is that I think the adults who see it are just as interested and surprised and really want to talk about it as the kids are. It's a universally engaging activity. So we have it's something I really encourage. And what it allows you to do is talk about how clouds form and why changes in solar energy would change what clouds are doing. It's a great way to start that conversation and to do some real teaching. I do have on our website tips for events and tabling, a blog post, and I talk about the cloud in a bottle and what the narrative is, kind of give a script for describing what's happening and relating that to the eclipse. So I encourage you to check that out if that's something you want to do. Other tips, if you're in a big group, a digital thermometer that relies on Bluetooth is sometimes challenging. I had a lot of interference and it was hard. The screen where the temperature was displayed had a hard time reading the probe. So I would recommend a digital display with a probe that plugs in directly instead of relying on Bluetooth. And then just be aware that cellular data on the day of the eclipse may be really difficult to access. And so make sure you have the app set up ahead of time, the training done ahead of time. You open the app well before the eclipse, before it gets too crowded. And then you'll be able to use everything without a problem. And then the indirect viewing methods are always really fun to play with during an eclipse, especially when you're getting a partial, because that's when the shadows get really cool. So again, that the tips and resources is on our website. I have that long URL there, but if you go to observer.gov and click news, you'll see those there. So here's the URL for that toolkit that I referred to. All of the activities that I talked about are there. And you can get the app, as I've said, at the App Store and Google Play. You can also follow us on social media. We'll be putting out a number of resources, some videos and reels, some science reels with scientists talking about some of the changes we expect to see. All of that will be on our social media pages, so I encourage you to follow us there. And then if you're interested, on March 21st and on April 2nd, we're going to have live Q&A events. So if you have questions, come on, go watch on our website. You can register for the event, get the Zoom link, come and join us and ask your questions. We would love to have you there. All right. Do you have any questions?
This was a great presentation. Thank you.
Thank you, Cal.
I appreciate this. And
You're welcome.
yeah, I think if anybody who sees this has questions, they should probably just reach out to Globe through the website, right?
Yes, they can do that certainly. My email address is at the beginning of on the first slide of the presentation, so they're welcome to contact me directly, or through our website. It's
And
just fine.
you're north of Albuquerque, so
I
time
am.
zone. People remember time zones.
Yes, yes.
Right. So cool. Thank you so much.